All right, so we're going to talk about naming alkanes. And alkanes are a hydrocarbon where all the carbons are singly bonded to each other. We're going to also call them saturated hydrocarbons, meaning that they have the maximum amount of hydrogen attached to all these carbons as possible. So let's look at C4H10. It's an alkane. Notice all the carbons are singly bonded to each other, and we have the maximum number of hydrogens that we can have. We can structurally make it this way with carbons attached to it in a chain, a straight chain, or we can have it attached this way, where we have 3 carbons in a row with 1 carbon coming out the center. They're both the same C4H10, but they're structurally very different. They actually have very different chemical properties, and they're used in very different ways. So how are we going to be able to distinguish between this guy and this guy if our structure is the same, if the chemical formula is exactly the same? Well, we're actually going to have to name them differently, and there's actually rules that we're going to abide by to name these different compounds so we can communicate amongst chemists in a better, more efficient way, so we can communicate well. So one of the lingos that we're going to actually discuss is a thing called a parent chain. And a parent chain is the longest carbon chain. So that's what we call the parent backbone, or the backbone of the carbon chain, also known as a parent chain. We also have within the parent chain, we might have side shoot-offs called substituent groups. And those are the side branches within those carbon chains. All right, so we got to name those side branches, and they're going to be used. The naming of them is actually very similar to how we name alkanes to begin with. We know we talk about one carbon, we are going to use the prefix meth. So if you have one carbon side chain, R represents our parent chain, we're going to say that's a methyl group. If we have 2 carbons, we're going to say that's an ethyl group. Don't forget S is a prefix for 2. If we were talking about a propyl group, we'd say 3 carbons attached to the parent chain. But we can actually rearrange this differently. We can have it attached this way, or we can have it attached to the central carbon. And we're going to call this, it's different, we're going to call this an isopropyl group. And then there's a butyl group, which is 4 carbons attached to the parent chain. And that can be also rearranged. We'll talk about that. And then you get back to our normal prefixes, like pentyl group, hexyl group, other prefixes we use when dealing with covalent bonding to begin with. All right. So let's actually, there are more rules when we're talking about this. Let's actually discuss them and do an example while we're doing that. So let's say we have this massive carbon chain with all these side branches and this really long carbon chain that might be used. You might see this when dealing with polymers and dealing with plastics or things like that. This is something like this is very common. So you have to be able to learn how to communicate that what kind of compounds we're dealing with. So the first thing we're going to do is count the number of carbons in the longest carbon chain. Okay, so we have to figure out what is a longest carbon chain. So let's count this. So let's look at the straight chain that we have at the bottom and count how many carbons are there. We can say 1, 2, 3, 4, 5, 6, 7, 8 carbons. But is there a possibility that we can have more than 8 carbons in a row? Well, just because it's bent doesn't mean that it's not part of a chain. As long as we go in a line or in the same, we don't break from that chain, then we can still call that a parent chain. So let's actually include these. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, 9 is larger than 8, so I'm going to say that this is my parent chain. It's my longest carbon chain. Okay, so now that I know my longest carbon chain, or my parent chain, I can go and then talk about the substituent groups. All right, we're going to number each carbon, giving all the substituents the lowest numbers. So let's make sure we know where our substituents are. We have 1 here, we have 1 here, and we have 1 here. Okay, so we have to make sure that these are the lowest number of carbons. So if we're numbering, we have to number the carbons in a way that these are in the lowest places. So we could either name it this being carbon number 1 and go 1, 2, 3, making this carbon a methyl group at carbon 3, or we can number it this way, going 1, 2, lower, and this this methyl group's at carbon 2. 2 is lower than 3, so we're going to go this way. So then we're going to make this carbon 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So now we're going to name the substituents. Well, we have 3 of them. If we have more than one of the same substituent, we're going to use prefixes. So the prefix for 3, we're going to go back to our normal prefixes, we know is tri. So we're going to call this trimethyl. We have trimethyl groups. Trimethyl. Okay, because we have 3 methyl groups. Methyl meaning 1 carbon each. If we have more than one side chain, name in alphabetical order. We don't have more than one side chain in this example, so we can skip this idea. Use hyphens to separate the numbers from words and the commas to separate the numbers. Okay, we have to figure out where these three methyl groups are. One's at group 2, one's at carbon 2, one's at carbon 4, and one's at carbon 7. So we're going to say 2, 4, 7 hyphen trimethyl, and what is this? This is nonane. So we're going to call this nonane, because don't forget the prefix non means 9. We have 9 carbons. And then we're going to end it with ane, because everything is singly bonded. This is an alkane, so we're going to end it in ane. So the name of this guy is 2,4,7 trimethyl nonane. Okay? We're actually going to go the opposite way. Let's look at something like this. Don't let this intimidate you. This is basically just directions on how to draw this carbon chain. So we're going to say 2,3-dimethyl 5-propyldecane. Well, first I know it ended in decane, and firstly I want to say that it's an ane, so it's a single bonded carbon chain. Dec, the prefix dec means 10, so I'm going to draw 10 carbons. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. At the 5th carbon, there's a propyl group. Don't forget propyl means 3 carbons. So at the 5th one, 1, 2, 3, 4, 5, there's a propyl group. 1, and I'm just going to go this way just for saving space, 3. So we have 3 carbons coming off of carbon 5. We're going to label this just for our 9, 10. Okay. Then we have 2,3-dimethyl. So we know we have 2 methyl groups, one at carbon 2 and one at carbon 3. So we have a CH3 here, and we have a CH3 here. This is essentially what we just did. See how easy this was? These are basic directions to get to this actual formula or this structure. Now I can just fill in all my hydrogens with where they go, because I know that carbons have to have 4 bonds. And I'm going to just fill in the hydrogens where they, to make it all correct. And so on and so forth. I don't need to do the whole thing, but you know, you see where I'm getting at. We'd fill all the carbons in, and then we can say this we just drew is 2,3-dimethyl 5-propyldecane, which sounds intimidating at first, but actually is not that bad. So these actually, don't forget these instructions, because these instructions will help you when you're naming alkenes and alkynes, double bonds and triple bonds. These are the basic instructions on how to name hydrocarbons.